Hello everyone, welcome to my 22nd video lecture on infinite series. In this video, we shall discuss about how to find the sum of infinite number of terms of the given infinite series by making use of the binomial series. So first let us try to know what is meant by the binomial series. So if we look at the binomial expansion of the function 1 plus x to the power r. So the binomial expansion of this, all of us know, it is first term to the power r, 1 to the power r is 1 plus rc1 into 1 to the power r minus 1 into x to the power 1, that is x, plus rc2 into 1 to the power of first term will be reduced. However, the first term is 1, therefore it will be remaining as it is, whereas the power of the second term will go on increasing. For the first term it was x to the power of 0, for the second term it was x to the power of 1, for the third term it will be x to the power of 2. Similarly, rc3 into x to the power 3 plus dot dot dot. In general, for the rth term in general for the nth term rcn into x to the power n, that is plus dot dot dot. So this is the binomial expansion of this function 1 plus x to the power of r. Therefore, if we simplify this series on right hand side, so then it implies 1 plus rc1 value is r into x as it is, plus rc2 value is r into r minus 1 by 2 factorial, that is into x square, plus rc3 value is r into r minus 1 into r minus 2 divided by 3 factorial, this is the value of rc3, x cube, plus dot 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 dot, plus rcn value will be r into r minus 1 into r minus 2 dot dot dot. It will go on like that and it will end at r minus n minus 1, that is this will be the last term, because for the term with x to the power of 3 it was that was rc3, it was r minus 1 r minus 2, that is 1 less than that of 3, therefore rcn must be ending at r minus 1 less than that of n, that is n minus 1. Therefore the numerator we have written and the denominator will be n factorial, rcn value I am writing here, into x to the power of n as it is, plus dot dot dot. So this is an infinite series we are having, and we observe that this infinite series will be convergent if the value of x, if the value of x is in between minus 1 and plus 1 again. So by making use of the ratio test, that is D'Alembert's ratio test, we can observe that this infinite series will be convergent between for all the values of x lying between minus 1 and 1, and for or it can also be written as the mod of x less than 1. So for this particular range of values of x, the given infinite series is convergent, and this infinite series will be taken as the binomial series. This series is called as the binomial series, and its value is considered to be 1 plus x whole to the power of r, because we have started with the expansion, binomial expansion of that function. Therefore this entire series is an infinite series known as the binomial series 1 plus x whole to the power of r. So now we shall have some simple cases of this particular series, and let us take it in the original form as series number 1. Now what happens to the series number 1 when r is equal to minus 1? When for r equal to minus 1, if we consider, then equation 1 implies, that is the series 1 becomes wherever r is there, let us substitute minus 1, so it will become minus 1. Here it will be minus 1 minus 3, it will be minus 1, we are substituting r is equal to minus 1, so it is minus 1 minus 1 minus 2 and minus 1 multiplied, minus minus cancelled, it will be 1 into 2 divided by 2, 2 cancelled, so it is only 1 remaining. So therefore we will be having the terms like 1 minus x plus x square minus x cube plus dot dot dot, in general minus 1 to the power n minus 1 into x to the power n minus 1 plus dot dot dot, or in this will be the left hand side of the series number 1, and on RHS it will be how much? It will be 1 minus that is 1 plus x, as it is r value is minus 1, that is 1 plus x to the power minus 1. So this expansion is turning out to be 1 plus x to the power of minus 1. So alternatively 1, every term will be there, 1 x, x to the power of 2, x to the power of 3, x to the power of 4 will be there. Alternatively positive negative signs, all odd powers will be having negative sign, all even powers of x will have positive term, positive sign. So this expansion is an infinite series expansion and its value is 1 plus x to the power of minus 1. So we shall be using this result in the solution of problems. Next, when r is equal to minus 1 and x is changed to minus x in the equation number 1, in the series number 1, when we put r is equal to minus 1, that is just this, like this we are going to get, and when we change xy minus x, then what happens? Or we can say it as equation number 2. In this itself we are going to substitute x is equal to minus x. For x is equal to minus x, equation 2, that is the series number 2. Series number 2 is the resultant of series number 1 for this substitution. Now in series number 2 we are substituting x is equal to minus x, so it is going to be 1 plus x here, minus minus plus x. So here my plus as it is, minus x whole square is again x square, minus as it is minus x whole cube is minus x cube, therefore it becomes plus x cube. Like that it will be going off, and on the right hand side it is 1 plus of minus x is 1 minus x whole to the power of minus 1. So this is another series we are going to use, call it as equation number 3. Now when r is equal to 2, what happens? For r is equal to 2, if we substitute r is equal to particularly minus 2, when we substitute r is equal to minus 2 in the given series 1, then that implies that is 1 minus 2x plus 3x square minus 4x cube plus dot dot dot. So this type of infinite series whose value will be 1 plus x to the power r, r is minus 2, that is. So this is another important series we will be making use, and call it as series number 4. Now when r is equal to minus 2, that has given us equation number 4. In this if we replace x by minus x, then what happens? For x is equal to minus x, equation number 4 implies, equation number 4 is the resultant of equation number 1 as a result of the substitution r is equal to minus 2. So we got this thing, in this we are going to substitute x is equal to minus x. So it is 1 as it is, minus x minus minus plus, it is plus 2x. Here it is plus 3x square, because minus x whole square is plus x square. Here minus 4 as it is, but minus x whole cube is minus minus plus, so it is x cube. Likewise all the terms will be positive, and in that case the series will become 1 minus x whole to the power of minus 2. So this is another series, call it as equation number 5, that is series number 5. Now like this we are going to have these important results. Along with them we are having one more very important result, that is when r is equal to a rational number p by q. So these are the cases when r is particularly minus 1 and minus 2. Now when r is a number of the form p by q, then what is the result? For r is equal to a number of the form p by q, that is a rational number if we consider, and q is not necessarily 0, where q is not equal to 0, that we have to mention, denominator should not be 0. In this case what happens to equation number 1? In that case equation number 1 results in the form, so you look at equation number 1, it is here 1 plus p by q into x, p by q into bracket p by q minus 1 divided by 2 factorial, p by q minus 1, p by q minus 2 divided by 3 factorial, and so on. So this is going to give us So as I have told you, it is 1 plus r value is p by q, that is let us write p by q divided by 1 factorial, we can write it as, and it is x remaining as it is, plus, so it is p by q into bracket p by q minus 1 divided by 2 factorial into x square, plus the third term will be p by q into bracket p by q minus 1 into p by q minus 2 divided by 3 factorial into x cube plus dot 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 so on. And on RHS we will be having, on RHS I am writing RHS here, it is 1 plus x whole to the power of p by q. So this is the RHS of this series. Now if we simplify this, we are going to get 1 plus q we shall take in the denominator of x, so it is 1 plus p by 1 factorial, let us write it as, into bracket x by q, p by q has been written like this, plus let us take LCM in the bracket p by q minus 1, so that results in the form of p minus q divided by q, and that q and the earlier q, you look at the terms which are present here, that is, here we are taking LCM. If we take LCM here, it is p minus q whole divided by q, taking after taking q as an LCM, so that q and this q becomes q square, let us write that q square with this particular x square. So therefore what happens to the simplified form, it is in the bracket p into bracket p minus q remaining, and the denominator q and this q in the denominator of p both will become q square, that q square will be written along with x square in this particular bracket, so it is x by q whole square, and here 2 factorial is there, let us keep it as it is, plus similarly this term is going to be p into bracket p minus q after taking q as an LCM, and here in the second term also if we take q as an LCM, it is p minus 2q remaining in the bracket divided by 3 factorial is already there, and we are having p by q, here LCM q, here one more LCM q, so totally q cube, so that q cube can be written as x by q whole cube, so like that, and this is plus dot dot dot, and this infinite series is having the value 1 plus x whole to the power of p by q. This is one of the most important results. We will be using this for solving our further problems, and let us call it as series number 6. So this is one more very important result we have obtained as a result, as a special case of the given binomial series. Now from this what we are going to get, when x is equal to minus x, we are going to get here the expansion for 1 minus x whole to the power of p by q, so that is for x is equal to minus x, equation number 6 implies what happens to this series, it is 1 plus p by 1 factorial as it is, this is x becoming minus, therefore this is going to be minus here, so all odd powers will have minus and even powers will remain as positive. This is an even power, it remains as it is, p into bracket p minus q divided by 2 factorial into bracket x by q whole square, and this is an odd power of x, that is x by q whole to the power of 3, we are having an odd power, therefore that is going to give you minus sign on substitution of x with minus x, therefore it is minus p into bracket p minus q into bracket p minus 2q divided by 3 factorial into x by q, x is minus x, that minus has been taken over here, it's a cube, and like that, so this infinite series is 1 minus x, because we are substituting x equal to minus x, p by q as it is, so this is another important result, take it as equation number 7. Now when we substitute q equal to minus q, so what happens when we take q equal to minus q, then result number 7 implies for q equals to minus q, let us see what happens to result number 6. In the result number 6, if we substitute q equal to minus q, this term is going to be negative, this becomes p plus q, and this is again minus. So alternatively, so all the terms, this is minus q whole square will become plus, so alternatively minus plus minus sign will be coming, and each bracket will become positive, p plus q, p plus q, p plus 2q, like that the terms will be. So therefore the series number 6 is going to give us 1 minus p by 1 factorial into x by q. It was earlier 1 plus p by 1 factorial into x by q, but we are writing q equal to minus q, therefore this minus sign has come over here. And now plus as it is, now here this 2 factorial as it is, this p as it is, this p as it is, but minus q becomes minus of minus q, that is p plus q now. So bracket has now become positive, and this is x divided by, in place of q if we write minus q whole square is again plus q square, so it remains as it is. But in the case of the odd power, so it is minus sign, plus, it is actually plus there in equation number 6. P into bracket p minus q becomes p plus q, because q is replaced by minus q. P minus 2q becomes p plus 2q, divided by 3 factorial as it is, into x divided by q whole cube. Q is minus q whole cube becomes minus q cube. Minus sign has been taken here, q cube has been written here, plus dot dot dot, and on RHS it is 1 plus x whole to the power of p by minus q, therefore it is minus p by q. Let us write it as, so it is minus p by q. So if we have this type of expansion, we can simply write down this thing as a summation of the series, and it is series number 8 we are using it as. And the last one is in equation number 7, that is in this equation, when we replace q by minus q, then what happens? So each term will become positive, that's all. So for q equals to minus q, equation number 7, which we obtained as a special case of equation number 6, now it is becoming entirely positive, that is 1 plus p by q into, p by 1 factorial into x by q, plus p into bracket p plus q divided by 2 factorial, because q is replaced by minus q, 2 factorial into x by q whole square, plus p into bracket p plus q into bracket p plus 2q divided by 3 factorial into x by q whole cube. So likewise the terms will be there, plus dot dot dot, that is equal to 1 minus x whole to the power of p by q is already there, but we are replacing q by minus q, therefore it is minus p by q. This is another important series, that is series number 9. So these are the series we are going to use while solving the problems. So let us consider the examples on finding the sum of the infinite series using the binomial series, which we have discussed in 9 different forms. So thank you for viewing this video. We shall consider the examples in the next video. Thank you.